Alrighty guys, bear with me. This is my first time using this technology, but I wanted to try to put this together to help you out. I'm going to use an example that's very similar to the example you have on your homework, but I'm going to use some different numbers. So the percentage of my population that will be homozygous dominant will be 64%. 32% of my population will be heterozygous, and 4% of my population will be homozygous recessive. The first thing that I'm going to do is convert all of my percentages into decimal points, because when we use the Hardy-Weinberg equation, we of course are going to use percentage points. That's not the word I'm looking for, decimal points. And I want to encourage you guys to put that leading zero in front of the decimal point. That way you remember you are working with decimals. From here, I need to figure out, am I working with my P and Q, or am I working with my P squared, my 2PQ, and my Q squared? Well, I know that P and Q are my allelic frequencies, and P squared, Q squared, and 2PQ refer to my genotypic frequencies. The easiest way I can help you guys remember this is I have two alleles, one from mom and one from dad. But I have three genotypes: homodominant, hetero, homorecessive. Therefore, I'm talking about P squared instead of P and Q. How do I take P squared and make it P? Well, I'm going to square root both the P squared as well as the number 0.64. The square root of 0.64 is, of course, 0.8. You now have P, which is the frequency of your dominant allele, which is exactly what is being asked of you in part 8. All right, so from here I'm going to use my P plus Q equals 1 equation, and I'm going to plug in Q after I figured out that 1 minus 0.8 equals 0.2. I'm going to use the example number 9 on the homework and carry on with the idea that Tay-Sachs disease is caused by a recessive allele, and I want to know the frequency of this allele. Well, I'm looking for, of course, the frequency of my recessive allele, which refers to Q instead of P. The math we did just above, where Q equals 0.2, would be the answer, the allelic frequency of Q. The next question I'm asking is, how many people in the population have Tay-Sachs? Well, I don't care about the heterozygous people. It's a recessive inherited disorder, which means I'm just looking at the people that got both recessive alleles from their parents. I'm looking for the homozygous recessive individuals. If we make a population of 1,000, it's really nice, easy math. How many individuals will have Tay-Sachs? Well, I'm looking for the individuals that are that have gotten both recessive alleles from their mother and their father. Therefore, I'm looking for the homozygous recessive individuals. Our homozygous recessive individuals are calculated by finding Q squared. Homozygous recessive is the equivalent of Q squared. 0.2 times 0.2 equals 0.04. Using our population of 1,000 individuals times 0.04, our Q squared number, we can figure out that there are 40 individuals in our 1,000-member population that would be diagnosed with Tay-Sachs disease. For the last part, I want to know, what if I was looking at a heterozygous individual, or the individuals that were carriers? For heterozygous, I'm looking for 2PQ. So the simple math is 2 times P, which we identified earlier as 0.8, times 0.2. 2, which we identified as Q. That gives me 0.32. Looking again, how many individuals are going to be carriers in my population? 0.32 times our 1,000-member population gives me 320 individuals that are diagnosed as carriers.